Hey, today in the philosophical Wednesday, and today I will talk with you about the quite interesting and fascinating paper from 1972 by Philip Anderson. Actually, it's the physicist, and he wrote the paper with the name that more is different. Yeah, and we talk that complexity is hard and simplicity it's even more harder. Yeah, and I have an article about the simplicity of the software design. But on his paper, actually, he raised quite interesting topic that he criticized the reductionism. So what it means that um, the message is quite simple that the whole is not always the sum of the parts, right? So we could not, for example, reduce the physics to the mathematics or chemistry to the physics and biology to the chemistry and so on, because on every level, the new complex system create completely different characteristics, properties, and interactions that we need to study. And it's mean that if something more complex emerge, they bring the own things. So if you add something that uh, similar in a big quantity and you create something completely different and you need to study it differently. And this principle that more is different actually could be applied heavily on so many things in software design and in knowledge management, knowledge representation, and also in IE management, memory management, and all other things. Because you know that uh, the complexity requires sometimes completely different things. And even with the mathematics, yeah, we needs to invent some different theoretical basis to describe something more complex. And for example, it's a good illustration of the set theory and type theory and all the things that we faced with some paradoxes, and then we just change the thing. And if you're talking about software architecture, we have completely big domain of the scaling applications, because a lot of patterns, a lot of good ideas on the small code base looks elegant and nice, but when you try to scale it on the massive amount of requests, for example, on the backend, it's just fail apart. Yeah, so the symmetry is broken in a software architecture when we try to build something heavy and something big. So and the same. So we have a lot of properties that in a scale will grow. That the bug rate, that the enterprise systems have completely different requirements and all of things. So the more is different, and it's sometimes it's completely different. Yeah, and uh, exactly. So it could be applied for the knowledge representation and knowledge domain. So small scale knowledge graphs behave completely different, and maybe they not enough or powerful enough for the reasoning. But when amount of your data grow, you get completely different capabilities. But together with the completely different capabilities, you need to have completely different reasoning, processing, and organization tools. Because if you want to manage the data at scale, you really could not rely on something that was work quite well for the small amount. Yeah, and it's yet another. The more is completely different, and sometimes you just need to even change completely the storage and optimize the queries and to do some the normalization of the data and the rest of the things. So and yeah, and the same applied to the AI agents and the memories heavily, because it's obvious that you know when you have the small agents, you have the small models, you have completely different capabilities, and with the growth of the model, with the growth of amount of the data, you get more and more complex relations and quantitative properties and abilities of the system to reason, to predict, and then you need to apply completely different, maybe models even to move forward. And yeah, so and it's explain us quite a simple thing that for the complex system, for the big scale system, we need completely different methodology. We need to think differently. We need to understand that we could not just, reduct it to something that was working quite well on the small scale. And yeah, so we need to work on the emergent properties more. We need to understand the complexity more. But the main thing that we should not be scared with the complexity. So a lot of people do this mistake that when they see that the processing is complex and you operate with something uh, hard. A lot of, especially managers, step back because they scared, because they don't know how to manage it, because they see the risks, and sometimes, yeah, they just don't want to do the stuff that complex, and they prefer more simple solutions. But the trick is simple that more is completely different. And I really recommend you to read the paper, but it's more about the science and physics, but it's give you a lot of insights and interesting could provoke the interesting thought process because how to handle something that are completely different because of the complexity that it's introduced. So that's all that I was keen to share with you today, and see you next time. Choose.